Your grandpa's generation could build things we literally cannot make anymore, not because the technology disappeared, but because the humans who knew how to use it all retired and nobody bothered to replace them. We're talking precision machinists who worked to tolerances thinner than a human hair, welders who could join nuclear-grade pipes with their eyes closed, and troubleshooters who diagnosed factory equipment failures by listening to the hum. But starting in the 1990s, companies across America made a bet. They figured computers and automation would replace these old-timers, so why waste money on apprenticeships that take a decade? Fast forward to today, and aerospace projects are billions over budget. Nuclear plants can't find qualified maintenance workers, and entire production lines sit idle because nobody alive knows how to fix the machines. Some of these skills are gone forever, and the consequences are still unfolding right now. Picture a machinist in 1975 standing at a manual lathe in a factory that smells like cutting oil and hot metal. He's working on a turbine blade for a jet engine, and he needs to hold tolerances of 0.00001 inches, that's 1/10,000th of an inch, thinner than a human hair. And he's doing it by feel, no computer, no digital readout, just a micrometer, his hands, and 15 years of experience. These guys could read measurements by the resistance of the tool against their fingertips. They could hand-lap parts to optical flatness, meaning so perfectly smooth that light itself couldn't find an imperfection. The training pipeline was brutal. You started as a teenager sweeping floors. By your 30s, if you were good, you were trusted with the critical work, the stuff that couldn't fail. They made turbine blades for aircraft engines, hydraulic components for submarines, medical implants that had to be absolutely perfect because they were going inside human bodies. But by the 1990s, companies looked at these guys and saw dollar signs walking out the door. CNC machines were getting better, right? You program the machine, press a button, and it cuts the part. No need for all that expensive human expertise. Except they were wrong. Turns out, CNC machines are incredible for high-volume production, but for complex one-off components with compound curves and internal geometries, computers can't do it, not even close. So what happened when all those machinists retired? In 2015, a major aerospace manufacturer had to delay a turbine upgrade program by 8 months because they couldn't find anyone who could hand-polish the internal passages of the blades to the required finish. The CNC could rough it out, but the final work required a human touch that simply didn't exist anymore. They eventually found one retired machinist willing to come back as a consultant. He was 73 years old, and they paid him more in 6 months than he'd made in his last 3 years before retirement. That's where we are now, scrambling to hire back the same people we pushed out, paying them triple, and praying they don't die before we can finish the project. But precision machining was just the warm-up, because this next skill was even more critical, and losing it put lives at risk. Welders who could join pipes for nuclear reactors. One bad weld and you've got a radiation leak. One weak spot and the whole system fails. So these weren't your average welders. These were specialists certified to weld in positions that would make your back hurt just thinking about them, creating joints so perfect they could pass X-ray inspection. We're talking about 6G position welding. That's overhead, upside down, at weird angles, often in tight spaces. And the weld has to be flawless because it's holding back thousands of pounds of pressure or radioactive material. The training took decades. You started as a regular welder, spent 5 years getting good, then maybe another 5 getting certified for pressure vessels. Then, if you were really talented, you'd spend another 10 years working your way up to nuclear-grade certification. By the time you were trusted to weld a reactor coolant pipe, you'd been doing this for 20 years. But in the 1990s and 2000s, these guys started retiring, and nobody replaced them. Because training a nuclear-certified welder costs serious money and takes serious time. Companies looked at that 20-year pipeline and said, "We'll just hire contract welders when we need them." Wrong. By 2010, nuclear plants across the country couldn't find qualified welders. One plant in Illinois had to delay a critical coolant system repair for 6 months. The oil and gas industry got hit even harder. In 2015, a major natural gas pipeline in Pennsylvania experienced a failure that investigators traced back to faulty welds performed by an inexperienced crew. The company had been trying to certify welders in 6-month crash courses for work that traditionally required 20 years of experience. It's like trying to teach someone brain surgery through a YouTube tutorial. And the few remaining master welders who hadn't retired yet? Companies were paying them consultant rates that made their old salaries look like pocket change. One nuclear-certified welder was charging $500 per hour in 2018. Not per day, per hour. Here's the really scary part. As of right now, the average age of a nuclear-certified welder in the United States is 58 years old. In the next 10 years, most of them will be gone, and the pipeline to replace them barely exists. So who's going to maintain the 93 nuclear reactors still operating in this country? Nobody knows, and that should terrify you. But it wasn't just the skills themselves that disappeared, because companies made one catastrophic mistake that turned a bad situation into a total disaster. In the 1990s, American companies decided that apprenticeships were too expensive. MBA culture had taken over corporate boardrooms, and the new priority was quarterly earnings, not 10-year training programs. So they just stopped training people. Sound familiar? Companies looked at their balance sheets and saw that training an apprentice cost them real money for years before that person became productive. From a spreadsheet perspective, it looked like waste. So apprenticeship programs got slashed. Between 1980 and 2000, the number of registered manufacturing apprenticeships in the United States dropped by more than 50%. But here's the problem. When everyone stops training, there's nobody left to hire. And it gets worse. Even when companies kept older workers around, they failed spectacularly at knowledge transfer. You know what happened all across America in the 2000s? A master machinist or welder would retire on a Friday. They'd have a little party, get a cake, shake some hands, and on Monday, a new hire would show up to take their place with zero overlap. Zero. No shadowing period, no months of working together, no chance for the old-timer to pass down the tricks they'd learned over 40 years. The institutional knowledge walked out the door and never came back. And the documentation? Forget about it. Most of these skills were never written down. They couldn't be. How do you write down what it feels like when a bearing is about to fail? How do you document the exact sound a lathe makes when the tool is chattering versus when it's cutting clean? That knowledge only exists in someone's head, built up through thousands of hours of experience. But companies didn't care. They cared about quarterly reports. They cared about stock prices. Long-term thinking became a luxury nobody could afford. Take Boeing. In the 2000s, they started experiencing serious production delays. When they investigated, they found that huge portions of their experienced workforce had retired, and the replacements simply didn't know how to do certain jobs efficiently. Tasks that used to take hours were taking days. General Electric had the same problem. So did Ford, Lockheed Martin, and basically every major American manufacturer. They'd all made the same bet that automation would fill the gap. Turns out they were wrong, and here's what really stinks. This is still happening. Right now, Companies are still prioritizing short-term profits over long-term knowledge preservation. They're still letting experienced people walk out the door without capturing what they know. It's the same mistake over and over again, because when the consequences finally hit, they hit where it hurt most. The aerospace industry nearly collapsed under the weight of lost knowledge. We're talking about billion-dollar programs grinding to a halt because nobody knew how to do the work anymore. Take the Boeing 787 Dreamliner program. Launched in the early 2000s with massive fanfare, it was supposed to revolutionize air travel, but the program hit catastrophic delays, racking up years of setbacks and billions in cost overruns. And when investigators looked into what went wrong, a big part of the problem was experience gaps. Boeing had outsourced huge portions of the work to suppliers who didn't have the institutional knowledge to build aircraft components, and Boeing's own workforce had been gutted by retirements in the 1990s. The people who knew how to integrate complex systems, troubleshoot composite layup problems, manage tolerances on thousands of interconnected parts, gone. Composite layup specialists were particularly critical. These are workers who hand-lay carbon fiber sheets in precise orientations to create lightweight, incredibly strong structures. The material has to be positioned perfectly, air bubbles eliminated, resin content controlled. One mistake, and the part fails, possibly catastrophically, at 35,000 feet. But by 2005, most of the experienced composite workers had retired. New hires were learning on the fly, making mistakes that the old-timers would have caught immediately. The 787 program ended up being nearly 3 years behind schedule. The delays cost Boeing an estimated $50 billion when you factor in penalties, lost sales, and additional development costs. But here's the really infuriating part. Companies that had refused to invest in training were now hiring back their own retirees as consultants at 3 times their old salaries. A composite specialist who'd been making $75,000 per year was suddenly billing $250,000 to come back and fix the problems their absence had created. It's the corporate equivalent of burning down your house to save on heating bills, then paying a premium to rent a hotel. Lockheed Martin faced similar issues with the F-35 fighter program. Northrop Grumman struggled with the B-21 bomber. Across the industry, programs were delayed and costs ballooned because the workforce didn't have the skills to execute. But here's what really matters. This isn't just about money. This is about national security. While American aerospace companies were fumbling around trying to rebuild their knowledge, China was investing heavily in continuous training programs. The result? China's aerospace industry is now competitive with the United States in ways that would have been unthinkable 20 years ago. We're literally losing our competitive edge because MBAs in the 1990s decided that quarterly earnings were more important than long-term capability. And if you think aerospace delays are just an inconvenience, wait until you hear what happened in industries where skill gaps didn't just cost money, they cost lives. When nuclear plant maintenance goes wrong, people die, communities get evacuated. Radiation leaks contaminate entire regions for generations, so the people who maintain these facilities need to know exactly what they're doing. But starting in the 2010s, the nuclear industry faced a retirement crisis that should have terrified everyone. The average age of nuclear-qualified maintenance workers hit 55 years old, and these weren't jobs you could fill with recent graduates. We're talking about specialists who understood radiation shielding installation, containment vessel inspection, and valve maintenance on systems where the margin for error is zero. The problem? By 2015, most of the technicians who'd been doing this work since the 1970s and 1980s were gone. In 2012, a nuclear plant in Ohio had to delay critical maintenance on its primary coolant system for 9 months because they couldn't find qualified workers. During that time, the plant was operating with aging valves that were overdue for inspection. Was it dangerous? Probably not immediately. But it was the kind of risk that compounds over time. Another facility in South Carolina experienced a near-miss incident in 2016 where improper maintenance on a backup cooling system went undetected for weeks. The technician who'd performed the work had only 2 years of experience. The job required someone with at least a decade of hands-on knowledge. This was completely preventable. The industry knew for 20 years that retirements were coming. They had demographic data. They could have started training programs in the 1990s. But they didn't, because training nuclear technicians is expensive and takes years. So instead, they scrambled. Emergency training programs popped up, trying to certify workers in 18 months for jobs that traditionally required 10 to 15 years of experience. It's insane. The medical device manufacturing industry got hammered even harder. Pacemakers, artificial joints, surgical implants, all of these require precision manufacturing to tolerances that make aerospace look forgiving. Because if a pacemaker fails, it's failing inside someone's chest. In 2014, a major pacemaker manufacturer had to recall over 400,000 devices because of potential defects traced back to manufacturing inconsistencies. When regulators investigated, they found that the company's experienced quality control staff had been replaced by workers with minimal training. People died. Not a lot, but enough. Patients whose pacemakers failed prematurely. People who needed emergency surgeries because their implants degraded faster than expected. And the workers who were left? They weren't incompetent. They were doing their best, but they'd been set up to fail by companies that refused to invest in proper training. Right now, nuclear plants across the country are maintained by skeleton crews of aging experts supplemented by less experienced workers. The industry is desperately trying to hire back retirees. One nuclear valve specialist came out of retirement at age 71 to help a plant in Illinois. He was billing $400 per hour because nobody else could do the work. Our nuclear infrastructure, our medical device industry, they're being held together by 70-year-olds who should be enjoying retirement but can't because we failed to replace them. And nuclear plants are at least regulated. This next industry lost skills with almost zero oversight, and the consequences cascaded in ways nobody predicted. There's a type of knowledge that can't be written down, the ability to diagnose what's wrong with complex machinery by sound, smell, or vibration. Computers can't do this. Sensors can't detect it. Only 40 years of hands-on work could teach you that a particular whine means a bearing is about to fail. And now that expertise is gone. We're talking about troubleshooting specialists who could walk into a factory, listen to a machine for 5 minutes, and tell you exactly what was wrong. They didn't need diagnostic equipment. They just knew. Old-timers could hear a bearing failure coming 3 weeks before any instrument would pick it up. The pitch would change slightly, a barely perceptible shift that meant wear was accelerating. They'd order the replacement part, schedule the maintenance, and swap it out before anything broke. That saved companies millions. Because unplanned downtime in manufacturing is catastrophically expensive. If a critical machine goes down unexpectedly, production stops. Workers stand around, orders get delayed, customers get angry. But you can't do planned maintenance if you can't predict failures. And you can't predict failures without that deep sensory knowledge. So here's what started happening in the 2010s. Custom manufacturing equipment, machines built in the 1970s to do specific jobs, would break down, and nobody knew how to fix them. The original builders had retired or died, the manuals were long gone, the institutional knowledge had walked out the door. A steel plant in Pennsylvania had a custom rolling mill that stopped working in 2016. This machine had been running for 40 years, producing specialized steel shapes that no other equipment could make. When it failed, engineers spent 4 months trying to diagnose the problem. 4 months of production stopped. The downtime cost the company an estimated $8 million. And here's the really maddening part. The guy who built that machine had retired in 2005. He'd offered to train younger workers before he left. The company said no thanks. They were not fine. Similar stories played out across every manufacturing sector. Automotive plants had custom presses that only 1 or 2 people knew how to maintain. When those people retired, the knowledge died with them. Chemical plants had mixing equipment with quirks that were never documented. Food processing facilities had lines that required specific adjustments based on temperature and humidity. All of that invisible expertise gone. When you can't fix critical equipment quickly, you can't meet production schedules. When you can't meet schedules, you lose customers. When you lose customers, you lose market share. In 2018, a major automotive supplier lost a contract worth $200 million because they couldn't guarantee delivery timelines. Why? Because 3 of their critical machines were maintained by workers who'd just retired, and the replacements couldn't keep them running reliably. Some companies, in desperation, started buying broken versions of their old equipment just to study them. They'd hunt down decommissioned machines at scrap yards and try to reverse engineer how they worked. It's like buying a broken car to figure out how your car operates. The technology didn't replace these people. If anything, it made them more necessary, because modern equipment is more complex, more interconnected, more dependent on subtle calibrations that only experience can teach. But we didn't figure that out until it was too late. So what specific skills are gone forever? The list is longer and more devastating than you might think. Here's what we can never get back. Hand-lapping telescope mirrors to optical precision. This was an art form practiced by a handful of specialists who could grind and polish glass to tolerances measured in wavelengths of light. The last master craftsman retired in the 2000s. Now we use computer-controlled machines that are good, but can't replicate the absolute perfection these guys achieved. Riveting large aircraft structures by teams. During World War II and through the 1970s, building an airplane meant coordinating teams of riveters who worked in perfect synchronization. For vintage restoration or specialized applications, the skill is essentially extinct. There are maybe a dozen people left in the world who know how to do it properly. Gone forever. Forging Damascus steel patterns in industrial quantities. True Damascus steel, with its distinctive wavy patterns and legendary sharpness, was a metallurgical art that required understanding carbon migration and temperature control at an intuitive level. The industrial-scale production knowledge is lost. Reading analog instrument panels in real time across complex systems. Power plant operators used to monitor dozens of analog gauges simultaneously, processing information faster than any digital system. They could spot anomalies instantly because they knew what normal looked like across the whole panel, tuning mechanical systems by ear. Whether it was engines, turbines, or production equipment, old-timers could tune performance by listening to the harmonics. You can't teach that from a manual. It took years of daily exposure. And here's the big one. Rebuilding equipment from the 1950s through 1970s. Tons of factories still run machines from this era because they're built like tanks and do jobs that modern equipment can't replicate. But when they break, we're screwed. No parts, No manuals, no one alive who built them. Some industries have tried to preserve this knowledge. Oral history projects where they interview retirees on video, heritage craftsman programs where museums employ the last practitioners of dying skills. But it's too little, too late. You can't learn feel from a video. You can't absorb 40 years of experience from an interview. The knowledge these people carried wasn't just facts. It was muscle memory, pattern recognition, intuition built through repetition. And we threw it away. The few preservation programs that exist focus almost entirely on luxury items or historical artifacts. Sure, we'll pay someone to hand-forge decorative ironwork, but industrial manufacturing skills, the ones that actually matter for keeping society running, nobody cared until it was gone. Some companies finally realized their mistake around 2020. After 2 decades of struggling with knowledge gaps, they started launching apprenticeship initiatives. 20 years too late. The people who could have trained the next generation are dead. The continuity is broken. You can't just restart a tradition that took generations to build. It's like trying to revive a language after all the native speakers are gone. Sure, you can teach the grammar, but the culture, the context, the lived understanding? That's lost forever. There's also a cultural loss here that goes beyond specific techniques. Apprenticeship culture itself, the idea that mastery takes time, that you learn by doing under the guidance of someone who's already mastered it. That whole mindset has been degraded. Modern corporate culture wants everything fast. 6-month training programs, rapid deployment, immediate ROI. The idea of spending 10 years developing an expert seems ridiculous to most companies now, but that's exactly what certain skills require. So, can we get any of this back? Well, some industries are trying, and the results are about as good as you'd expect. Some industries are trying to rebuild what they lost. The results? Not great. Crash apprenticeship programs are popping up everywhere, trying to certify workers in 18 months for jobs that traditionally took 15 years to master. These programs produce workers who know the basics but lack the depth that comes from years of experience. They can follow procedures, but they can't improvise when something goes wrong. And in manufacturing, things always go wrong. Then there's VR training for manual skills, which is about as effective as learning to swim by watching videos. Sure, you can simulate the motions of welding in virtual reality, but you can't simulate the feel of metal under your hands, the smell of overheating material, the vibration that tells you something's not right. It's a laughable substitute for 10,000 hours of practice. Companies are also hiring consultants from retirement, paying premium rates for people who should be fishing or spending time with grandkids. It's a Band-Aid solution. These consultants will die eventually, and then what? The knowledge dies with them. Again. Some organizations are trying to reverse engineer old equipment by studying broken machines. It's expensive, time-consuming, and produces incomplete results. You can figure out what parts do, but you can't capture the intuition of why certain adjustments matter. Why isn't any of this working? Because you can't compress 20 years of learning into 2. Tacit knowledge, the kind that exists only in muscle memory and pattern recognition, can't be taught in classrooms or simulated in computers. It has to be lived. Germany figured this out decades ago. Their dual education system, where students split time between classroom learning and on-the-job apprenticeships, preserved way more manufacturing expertise than we did. German companies still have multi-generational knowledge transfer. They didn't lose their institutional memory because they valued continuity over quarterly profits. Meanwhile, American infrastructure, defense capabilities, and energy systems are all dependent on shrinking pools of aging experts, nuclear plants maintained by skeleton crews, defense contractors struggling to build weapons systems, power grids vulnerable because the people who understand them are retiring faster than they can be replaced. We traded long-term resilience for short-term earnings. Turns out that was stupid. And the next generation is even worse off. Fewer young people are entering skilled trades because we've spent decades telling them that college is the only path to success. Meanwhile, all the promises about AI and automation replacing these jobs? Complete nonsense. AI can't weld a nuclear-grade pipe. Robots can't diagnose a bearing failure by sound. So here we are, sitting on a pile of critical infrastructure held together by retirees who can't retire and inadequately trained workers doing their best with insufficient knowledge. But if you thought losing skills was bad, wait until you hear what happened when we lost entire industries. The manufacturing sectors that moved overseas and can't come back, the supply chains that broke permanently, and the strategic vulnerabilities we created by outsourcing everything that matters. Click here to watch that video because this one's over. And trust me, it gets worse.